Hello, everybody. As I am working at the crossroads between data science and network science, I thought of making a short video presentation on a piece of my current work. This is about a bibliographic study of the field of social justice, the way it is grappled within or from the angle of library information science and computing in general. The data I have been collecting are coming from the Web of Science, and they are spanning a time period starting from 1913 and going until now, the end of 2020. And actually, the collected data set, downloaded as a CSV file, it includes the following 68 variables. Too many of them, but I'm simply focusing in three main variables, and these are the year of the publication year. It's also a coding of the publication composed of first author and year. And then I am merging the three variables described in the Web of Science dataset as the author keywords, the keywords plus, and the abstract. Everybody knows what an abstract is. The author keywords are the keywords which are given by authors themselves. The keywords plus are the keywords given by the Web of Science. And in this way, by merging words from the abstracts, that is tokenizing and lemmatizing the abstract content and incorporating within it the keywords and the author keywords and the keywords plus, I am focusing on a very simple data frame composed of three columns, three variables: the year, the encoded publication name, as you see over here, and its publication associated to a list of keywords. Furthermore, I am going to do a topic modeling analysis using LDA, the latent Dirichlet algorithm, in order to derive a number of LDA terms, LDA keywords that I am also incorporating in the above list of keywords, which has come out from the data set of author keywords and keywords plus and the abstract tokenized words. Now, the topic modeling analysis is deriving five topics, and they are displayed over here. The first topic is about education. The second is about information. The third about research. The fourth about law. And the fifth about life. Everything is concerning the way social justice issues are discussed in this Web of Science dataset, bibliographic dataset. Now, you can see more information about the terms included in each topic over here, and next to the keywords, what we have is the word to topic probability. So the interpretation I have given to these five topics, education, information, research, law, and life, comes from the most dominant keywords, as you can see in each topic. Now, why five topics? Because this is optimizing the coherence values as you can see over here. Now, let us do an elementary counting of all entities that we have in this data set. So what we've got is 1,246 keywords, all the keywords taken together, almost 300, that is 286 publications, and they are spanning 32 years after 1913. This is the time series of the number of keywords and publications per year. And now the most important in terms of frequency, or the top keywords, are the following. Of course, social justice comes first, but taking into account that this is an academic bibliographic data set, research, education, study come next, and so forth. This is the histogram of keywords, and of course, as you can see, and it is expected, it is obeying a power law. Now, let us do a computation of the tf-idf scores of the keywords, and let's see how these tf-idf scores, they vary over time. This is very important, and this visualization is given the essentials of this time analysis, because every keyword which is ranked in a higher or in a high tf-idf score, this is interpreted as indicating the fact that this keyword is representing the concepts of, or the things which have been discussed in the corresponding year and in the publications included there. So, for example, by going here, you can see in 2002, we have those keywords, and perhaps there is another one which is much better. Yeah, 2005, we have social justice most of the time and collaboration, and then we can get a feeling what is discussed in each year in these publications from the top tf-idf scores of keywords included in the publications of the corresponding year. And actually, we can do something better. We can filter keywords with tf-idf scores large enough, bigger than 0.2, and this is what we get now. The picture, it's a little bit more clear, and we can also decompose this tf-idf time series according to various time periods. So this is the first from the years until 2000, and then this is the second from 2000 until 2012, and this is, as you see, after 2015, there are so many publications, and actually this was obvious in this visualization of the time variation of the number of keywords. So it dramatically increases after the 2010s, and so it's a little bit difficult in order to understand what is going on. But now the coloring is as follows. Every color corresponds to a publication. So here, the red color is the publication is Squilema in 2013. This is the year. And every slice in the same color corresponds to a keyword. And this is in the subsequent periods. And then we can do the same type of visualization for the membership of keywords inside LDA topics. And for example, these are the dominant keywords having probability keyword to topic bigger than 0.01 in the topic of education, the first topic. This is in the second topic. In the third topic of research, and for example, let's see here, in 2010, it was about education and research, and these are actually the dominant keywords in this topic. And for the fourth topic about law, this is the decomposition of the most important keywords in terms of the corresponding probability. And this is for the last period, for the last topic, the topic about life. Now, this idea that for each year we have a number of words, keywords grouped inside different categories of tf-idf scores or inclusion in different topics, apparently gives rise to a hypergraph. And this hypergraph can be represented as a bipartite graph between publications and keywords. So for example, here on the periphery, we see different publications, and now they are connected to the keywords of the data set, which are located in the interior of the circular layout. So of course, the biggest one is the social justice keyword, and the diameter of these nodes is proportional to the number of keywords, to the number of publications that a keyword is connected to. So it's the degree of this node in the bipartite graph. And the same way around, for the diameter of the nodes of publications is proportional to the number of keywords included in this publication. Now, this is a temporal graph, and then we can see the transitions from publications in each year to the next, to the consecutive year. And this is described by this chain. So we're starting from the year 1913, and then we're going to the next year in the data set, which is 1960. And then we are annotating here, which are the keywords which are in common between this year and the previous one, and the new keywords. Now you can see we have two breaks, two interruptions. So there is a discontinuity from 78 to 1983, and then a second discontinuity from 85 to 87. And then, and also the width of the edge, which is depicting the transitions among keywords, the keywords transitioning among publications actually. This width, is proportional to the number of transitioning keywords. Actually, we're interested in issues about continuity or discontinuity in the occurrence of keywords. And to do so, we see that in the first period before the first break, so from 1913 to 1978, social justice always occurs. And then in the second period, it's just justice always occurring in the 3 years of this period. This is before the break. And then it's a whole mess for the last period. There are so many, actually it's very difficult to distinguish what is continuing or discontinuing. However, we can do something better. We can detect top keywords in terms of their maximum persistency. And the maximum persistency of a keyword is the maximum number of consecutive in the data set years over which years these keywords are always appearing. So their frequency is bigger than 0, or they're always activated, as one would say in the theory of temporal networks or longitudinal networks. So social justice is the prevailing one. And then we have research, we have education, and so forth. And we can also do the opposite. That is, we can compute the maximum intermittency interval, which is the maximum number of consecutive years over which a keyword is happening to lapse out, to intermit. So over here, of course, because the cutoff is 29 and we have 32 years, we are holding only keywords appearing either one or twice in the data set. Now, the last part of my discussion would be a very preliminary exploratory data analysis of the keywords we have been processing so far. And you see the box plots. In the box plot of frequency, the outlier of social justice has been deleted, has been subtracted. And then you see this indicator of maximum persistency, the one of maximum intermittency, the indicator of the tf-idf score, and the 5 topics probabilities, how they are distributed. I mean, the values they have, what are their distribution. And of course, in EDA, what is common is to do these pair plot comparisons between the 5 probabilities, the tf-idf score, and the maximum intermittency and the maximum persistency, together, of course, with the frequency of occurrence of a keyword over a year. So these are the pair plots, and I am not drawing any conclusions because the data set is rather simplistic. So it was sort of a toy data set in order to test methodology, the computational data analytic and network analytic methodology that I have been describing to you. So this is what I was intending to show you. And if you have any questions, just contact me. If you want to have access to a written form, the written manuscript of this publication, or the code which was written in Python that I have been using, please let me know and I will be happy to share it with you. Thank you very much. Stay safe. Bye-bye.